This is a tutorial on how to develop your own Lua extension modules for OpenCL Studio. Basically, this allows you to integrate your own source code with the development environment via a DLL that registers functions which will then become part of the scripting interface over here. So a few plugin modules already come with a download of OpenCL Studio, including the source code and the makefiles, and you can use these as a guide to develop your own extensions. So an example of a module is the XML package. So once you type in XML here in the scripting input window, dot, and up pops the code completion window that shows you all the functions that are part of this module. And you can use it to read and write XML files. If you'd like to see all of the packages that are installed, you have to go over to the Help tab and look under the plugin subdirectory where you can see all the DLLs that are currently being loaded by the editor. And down here we have the XML. So now here you can browse the API of all the modules, and once you have created your own DLL and put it in the proper directory, it will show up here as well. So the DLLs are physically located within the current workspace directory. So OpenCL Studio has a workspace infrastructure, and you can manage multiple workspaces, and each workspace has its own copy of the extension modules. So an empty workspace looks something like this. So at this point we're only interested in the bindings directory. It contains 4 subdirectories, and the first 2 are libbind and libcl. These one contain the bindings for the libcl open source parallel algorithm library. There is an entire video dedicated to this topic, so we're not interested in these directories right now. The next directory, liblua, contains the header files and DLL of the Lua scripting engine. Now all the plugin modules must include these header files in order to properly bind to the Lua interpreter. And on the bottom here is the plugins directory. Now this one contains all the extension modules currently installed. And here you can see the DLLs, which we saw earlier in the Help tab. And up here there are a number of directories, and each one of these directories contains a source code and Visual Studio project file to build this particular DLL. So when we go back now, you can see there is a single Visual Studio solution called plugins, which when we open up looks like this. And you will use this one to either edit the existing plugins or develop your own. So the first thing to note here is that this solution actually includes the libcl open source parallel algorithm library. And the reason being is that OpenCL Studio is actually built upon libcl, which means that internally it uses some of these base classes that are defined here. And the advantage of this is that if you pass a buffer that's been created within OpenCL Studio to one of your own modules, it will be of this data type. Now this is actually quite powerful. It allows you to integrate your own code very tight with the development environment. And so for example, the image and video modules are now capable of directly streaming videos and images into OpenCL buffers via this OpenCL buffer object that's passed to it from the development environment. And it also needs to be pointed out right now that some of these modules are required for the editor to start up. So if it does not find the image, mesh, or video modules, the development environment will not even start up. So but now let's have a look at the XML plugin. So in here we now have 2 CPP files, one called DLL main, and this one basically contains your standard DLL main function. We will not look at this any further. And the other one, xml.cpp, now contains the XML bindings. And this includes a number of functions that are in the proper format for the Lua interpreter to call. And at the very bottom here, we have a function table and a single function that's exported by this DLL called libopen. Now when OpenCL Studio first starts up, it goes to the plugin directory and it looks at all the DLLs in there. And if a DLL contains a libopen function, then OpenCL Studio will call it. And every libopen function has to at least call 2 Lua functions. One is called Lua register, which will register the functions in this method table with the Lua interpreter. And the first argument is a string, and it is basically the string that we'll later on use within the scripting window to identify your function. And here's a pointer to the actual C function that'll be called. After the register, you have to have a Lua pop call here. Now this particular module has a few more function calls that registers a garbage collector for this module with the scripting interpreter. Now not all modules need that, it depends on how you implemented yours. Now everything in this file except this single call to libopen is for the most part Lua specific. This means that it has nothing to do with OpenCL Studio. And there is lots of documentation on the lua.org website on how to integrate your own C functions with the scripting engine. So one way to create your own modules is simply to go ahead and make a copy of one of the existing ones. Do a little bit of renaming. You will also have to open the Visual Studio project file and rename, let's say, every instance of XML to the name of your new module. And then when you're done, you include your new Visual project file into the solution and compile, and you're ready to go. One thing to note is that each one of these projects, after it's done compiling, it copies the DLL one directory up into this root directory, the plugins. And here the editor will then find it. So next time you start up OpenCL Studio, your plugin will then appear here under this plugins list with a list of all the functions that you have created. And you'll be able to call it from over here just with name, dot, and up will pop the code completion window to show you all the functions available. So the one thing left to do is to create a help file for your module so that when the code completion window pops up here, you'll actually see some documentation, as well as over here under the help tab, when you select the different functions, you will see your documentation over here. And the way to do this is create your own help file and deposit it into the plugins directory next to your DLL. And here you can see we have our DLL file, xml.dll, and then below it there is another XML file with the same name, which contains our help. And when the editor starts, it reads the DLL file at the same time as it reads the XML file. And you can, if you look at the Visual Studio project right here, the XML file is included right here in our solution. And when you double click on it, you can see here a syntax that describes some documentation for each of the functions in the module. This file is fairly self-explanatory, and there is ample of examples in here that show you how to develop your own help files. So this ends the tutorial on how to develop Lua extension modules for OpenCL Studio. It does require a knowledge about the Lua scripting language, but it is well documented. And on top of that, OpenCL Studio does come with a number of extension modules already, including the source code, which should act as a useful template for you to develop your own.